All right, so I think this is recording. Let's take a look here at number 7. We have this function f of x is equal to negative 2x cubed minus x squared plus 15x plus 18. We want to factor it, and we do not have any skills yet to help us to do that. So the problem gives us a little bit of help and tells us that one of the factors is x minus 3. So you're like, well, okay, how does that help me? How do I figure out now the rest of it? If x minus 3 is a factor, how do I figure out the rest of it? Well, through division. And with division, rather than doing long division, it's a lot easier to use synthetic division. So remember, in factored form, you want to change the sign and have a 3 here. Now, for this function, we want to make sure that the exponents are in descending order, and it looks like they are 3, 2, 1, and a constant. No missing powers, so I don't have to put any zeros down here. All right. So with the synthetic division, the first number comes straight down. If the number is below the line, you multiply it by the number in the box, put it underneath the next number, and add. And that pattern just repeats. And we were expecting to get a 0 here. So now we can fill in what's here in this parenthesis. We can say that this is x squared, that this is x, and so I can come in and say this is negative 2x squared minus 7x minus 6. All right. Before I jump in and do my x method, I prefer, it helps me if that leading coefficient right there is positive. So I'm going to factor out a negative one. See how all these terms are negative? I'm just going to factor out a negative 1. So that's going to change the sign of all of these. It's going to change them all to positive. 2x squared minus 7x plus. I just said it was going to change the sign, and I almost didn't change the sign. I'm going to shrink this up to give myself a little bit of room. All right, so now when I come over off to the side, you can put it directly over the middle term. I just do it off to the side to keep that from getting all cluttered up. 2x squared times 6 is 12x squared. And so now the game begins of finding two values that multiply together to give us the 12x squared, but add to give us 7x. So you might try 12 and 1. Well, that doesn't work. You might try 6 and 2. Well, that doesn't work. But if you try 4x and 3x, that'll work. And when you have a short list like that to go through, it's pretty easy to find. But boy, if that 12 were say a 36, you've got a lot of possibilities to go through, and sometimes then it's wise to kind of do some scratch work off to the side. Now, when the leading coefficient is not equal to 1, you're going to have to make a table, or some of you say chart it. So along one diagonal, we put the first term and last term from our polynomial that we're trying to factor. And along the other diagonal, we put the information that we found in our x. We search for that, and now we want to use it. So we factor both horizontally and vertically. 4x and 6 have a common factor of 2, and 3x and 6 have a common factor of 3, and 2 times 3 is 6, so hey, that helps. 2 and 3 don't have any common factors, but these two terms have an x that's common. And up here, they're both even numbers, and they have an x. So now we have factored it. So I'm going to move this negative 1 just out in the front here. And then, because we can multiply in any order that we want. And now this guy from my table over here, I've got x plus 2 and 2x plus 3. All right, so there's my answer, because that's all they want for now. Like I say, the next step would be set it equal to 0, give the zeros of the function, determine the multiplicity, describe how the graph intersects the x-axis. All of these would be touches. There would be no turn, or they would all be crossovers, and there would be no touches. Sorry about that. All right, I hope that helps, and I'll talk to you later. Bye.